I'm going to go through the rubric of the Math SL IA. This is something that I think has a little bit more meaning when you actually start writing it. But if you would like to look through this video before you have even chosen the topic, some people like to know what they're working toward. Basically, the total is 20 points, and each one of these categories is worth between like 1 and 6 points or something. So some things are worth 30%, some things are worth like 5 or 10%. So think about that when you are writing, that certain parts of this are worth more than others. Let's start first with communication. It's one of the most obvious parts of the IA. You always expect that some part of it is related to your writing. But look at this. Only 20% of the grade is related to the writing. And basically, if you look through the words that are written here, nothing ever said, they never talk about grammar, they never talk about spelling. What they want is something that is clearly understood. So if your grammar and your spelling are not that great, but it doesn't interfere with understanding, then that's fine. But, you know, why take the risk of having bad spelling if you can make sure that it's good spelling? Now, grammar sometimes is hard, but you can always have someone proofread your paper to make sure that the grammar is not too bad, okay? But like for people who are not native English speakers, you're not at a disadvantage because it really doesn't matter if your English is not that well written, as long as the math ideas are good and you use language adequately to make your arguments clear. Okay, so I'm going to just read some of the key words here, which are important for communication: organization, coherence, of course. You must have an introduction. You need to explain why your topic was chosen. You should say what the aim of the exploration is, or like if you have a question, that could also be the aim. Make sure it has a conclusion. There should be a logical development or flow to the paper. Graphs, tables, and diagrams are graded in a different category, but the placement of the graphs, tables, and diagrams, which means throughout the text, is part of organization and communication. So it should be in the appropriate place and not everything at the end, okay? All steps of the exploration should be clearly explained. You should have all ideas and concepts clearly explained. That goes for non-math ideas and math ideas. In the case of communication, that's where we put the grade for the non-math ideas. Like, for example, if you're going to write about horseback riding, all the horseback riding concepts need to be explained as if the person does not know anything about horseback riding. Okay? Let's see, concise. Don't put repeated stuff because if it's boring to you, it's boring to everybody. Okay? You do not need to put little titles like intro, rationale, conclusion, although some people do. You don't have to do that, okay? Cover page, normally it makes it look so much better if there is one. There's no point for a cover page, but if you do have a cover page, it means that you've definitely made a title, when a title is something that is actually, you get a point for. Interesting question. The question should be a question like in most IB, IAs, and extended essays, etc. It shouldn't be a question that has an obvious answer, okay? So that is a good way to make sure you have an interesting IA. Like I said, non-math ideas should be explained sufficiently. That's graded here. Citations for anything that is obviously taken from a different source. There's no formal citation system, so that makes it very easy to cite stuff. Just put it in the bibliography. You don't need to have footnoting or anything like that. You should explain the math procedure completely. Okay. Math presentation. So this is kind of corresponds to, like, you know how I grade your blogs and I criticize things that like about how you say something in math-wise or your notation. That's where I would take stuff off here. Appropriate notation and symbols. You should define any key math terms as if the person doesn't know what you're talking about, because you're the audience you're writing for is someone like in 10th grade or something, not for someone who knows as much as you do. You're not writing for the examiner. You should be writing as if you're writing for someone who knows a little bit less math than you do. The reason why is because how do we know as examiners whether you understand the math if you don't explain the math, right? You should use multiple forms of math representation, such as formula, diagrams and tables, charts, graphs, and models. You should use technology tools as appropriate. You should show math definitions. You should, and putting them in your own words is what makes it sound like you understand them. You should not use calculator and computer notation unless it's part of like a screenshot or something. If it's your work, you should not use computer notation. Computer notation would be something like using circumflex for the exponent. Define all variables and explain all variables. Okay. Personal engagement worth 20% of the grade. Wow. So, personal engagement is kind of vague to understand, but I try to put some hints here that are concrete ways of showing your personal engagement, like thinking independently and creatively. Okay, what does that mean? It's hard to tell, right? Address personal interest and show math ideas in their own way. Okay, I still don't know what's going on. Okay. By the way, I'm including all the descriptors here, but some of these descriptors are not very specific either. So I'm providing a lot more information here that you're gonna see in the rubric. So explain why it is interesting to you. Okay, so if you maybe you have a story about why this non-math concept is interesting to you, if you explain that and convince the person that it is interesting to you, then that's going to count for something. If you are able to explain this non-math idea in a way that is easy to understand and is interesting, that interest and excitement and expertise is contagious. It makes the reader want to know more and is convinced that you are also interested in it. That counts for something. If you are using very familiar math, if you apply it to a problem that maybe the person has never seen it applied to before, that shows personal engagement also. It's kind of original, right? If you link the results to your own life, that also shows that you're interested and impacted by the results that you obtained. If you are the one who personally collected the primary data, that also shows personal interest, right? As opposed to like collecting data that's already on the internet. Reflection worth 15%. So this is like one of the things that some people do very badly. If I ever read at the end of an IA that, oh, my results are pretty good because I got it from a reputable website like, they like UNICEF or something like that. Okay, first of all, that is the recipe for a really bad reflection grade. It shows that you are not reflecting at all. Okay, no matter how good the data is, whoever collected the data, including UNICEF, would be perfectly able to find flaws with their data. We don't have infinite time and money and perfect data gathering techniques. Nobody does. So there is no way any data is perfect. And if you cannot find one reason why the data is imperfect, then you haven't looked hard enough. Okay? And especially data that we ourselves generate, there is definitely problems with that. Okay? So critical reflection means you don't get any points for saying how great your data is and it's fine and there's no reason why it's wrong, okay? You get points for poking holes in your data and explaining why it's bad. That is not going to adversely affect any other category. The fact that you poke holes in your data and say why it's wrong, that gets you points here in reflection, okay? Talking about what comes next based on what you have done, that shows that you have looked at your data or looked at the last step and chosen the next step based on that. That shows you're reflecting about your data throughout your project. Reflection is not just something that happens at the end. Implication of results. At the very end, when you say, okay, here are my results, this can impact the world or me, because blah, 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 that shows that you are digesting your results and figuring out the significance to different people. Weaknesses of approaches. You chose a math approach to use, and although it might have been the best possible approach from the other approaches, there's definitely weaknesses to your approach that other approaches maybe did not have. Like overall, maybe it was the best approach, maybe just because it's cheaper and time permitted. But you definitely have to point out whatever problems there are with your approach, recognizing you have those. I mean, if you point out the weaknesses in whatever math process you did, you get points for that. If you don't, then the examiner is going to remove points for you not being aware of your weaknesses. And maybe you were aware of the weaknesses and you didn't want to draw attention to it, but that's like the silliest thing you can do, because you actually get points for drawing attention to weak parts of your work. Considering different perspectives. Okay, so maybe like you have an interpretation and a bias, and you have to recognize the fact that you're looking at everything with a bias. You need to point out ways that other people might interpret your results. That's definitely a good reflection when you do that. Again, good reflection happens throughout the exploration, not just at the end. Let's see. Further questions that are raised by your exploration. So like at the very end, maybe you do have some kind of conclusion, but the conclusion doesn't make like your IA the end-all be-all of IAs. After that, you can see potential for maybe a follow-up IA or more investigation to continue on work. Maybe it answers like a slightly different question, or it answers the question that you asked better. You should show that you are processing your results by making conjectures or guesses about the next thing that's going to happen. You can look at your results based on history or international perspectives. And when you analyze choices during the project, you also definitely want to look at the different approaches and point out why you chose the one that you did and what are the problems that you chose. What are the problems with the one that you did choose, okay? Just basically be very critical of yourself. Use of math. This is the one that weighs the most, 30%. But you can see that, like, you know, it's pretty easy to get like a 3 out of 6, right? As long as you do a pretty competent job. And so you can see that, like, if you only miss 3 points from here and you get every single other point, you got practically a 7 IA still, right? So, like, even if the math is not super, super great, as long as you do everything else great, which is not that hard to do, you can get a really good IA score, right? Okay. So, but I think that, like, you know, basically in the process of doing everything else well, you're going to end up with a really nice IA, even if you don't think that the math part is that sophisticated or anything. It doesn't take sophisticated math to get a 7 IA. It takes a good job in all these categories, okay? So basically the math that you choose has to be basically something from the syllabus is the safest thing. It could be something as difficult as a syllabus, but outside the syllabus, but you're just making your life more complicated. Definitely can't be stuff that you did not learn in our syllabus because it's something you learned in 10th grade only. That's not good. The math does not have to be perfect, but if you have any huge errors that like affect the results, then that could screw everything up. But if you just have some minor errors, those are not a problem. You can still even get the maximum grade, even with a few minor errors. Just like there's no reason to have minor errors though, right? It's like as long as you can complete the math part ahead of time and you are showing it to your teacher, then they're probably going to point out the huge errors before you get to the end. Okay? What usually where there's errors is like If you add stuff at the last minute that it's never been checked, that's usually when the huge math errors happen. You can have just a few small topics, or you can have one single topic. Basically, the objective is to do it well. Okay, you don't have to have 3 different math topics. Basically, it should be mostly correct. Understanding should be demonstrated. So that means you should be explaining each step as if the reader is a 10th grader and doesn't know the math that you're doing. That's the way you show your understanding, by explaining in depth the math that you are doing. You do not necessarily have to do a challenging math concept. You could take a familiar math concept as long as you apply it kind of originally to a new context. Modeling for real-world analysis or real-world situations is a very popular math idea. And I think everything else I said, exponentially, yeah. Oh, one important thing. Every time you talk about use of some math concept, you need to explain why the math concept was chosen. It might seem kind of obvious, and even if the explanation is obvious, you need to say it because the examiner doesn't know if you know that. Okay, so like for example, oh, I am using linear regression because linear regression is a technique used to find the relationship between 2 numerical quantities. In this case, I have this quantity and this quantity, and when one gets bigger and the other one gets bigger, then that would be correlated, blah, blah, blah. So you would want to explain that even though the examiner, of course, knows that already. Thank you.